something or not wanting it. This is feeling something or not, feeling pleasant or unpleasant states. Very different patterns of brain activity. So again, if you can imagine that if your device was sensitive enough, that, you might be able to identify exactly what pattern of brain activity is associated with a particular percept or a particular thought or a particular feeling. We still wouldn't have an answer to the hard problem, okay? We wouldn't know how it is that that pattern of brain activity generates the conscious experience of seeing, but at least we would have identified its neural correlate. Here at Berkeley, we can take this to an extreme, as Professor Jack Gallant has done with recent research that's made him quite famous, and quite justly so. This is an astounding technical achievement in which the Gallant and other individuals in his laboratory have been able to actually present an object to somebody visually and identify from the pattern of brain activity what the object is that they're looking at. Okay, this is way cool, as we say in science. Okay. What the Gallant's research, the Gallant Lab's research, takes advantage of what's known as the topographical organization of the visual system. Every point in your visual field, up here, 1, 2, 3, 4, 5, 6, 7, 8, every point projects onto a specific portion of the retina, okay, stimulating rods and cones buried in that portion of the back of the eye. And this topographical organization is carried through to the primary visual cortex, areas V1, V2, and V3, so that there's a particular portion of the spatial field that, when it's got a stimulus in it, actually activates a particular portion of say, area V1. Now, what Gallant and his lab have done, absolutely thrilling experiments, is to present a bunch of images to subjects, and over a large number of trials with very, very, very powerful computational methods, have been able to identify precisely what pattern of activation in primary visual cortex is associated with a particular visual stimulus. So here's work by Kendrick Kay, who's a graduate student here at Berkeley at the time. What they did was to present subjects over a long series of trials, repeated series of trials, with about 1,750 different pictures of things. Pictures stolen from the internet, just that's where we get our stimulus materials these days anyway. And what they did was to record subjects' patterns of brain activity using fMRI to each of these stimuli. A single subject, in this case, just to kind of make sure it's as clean as possible. And what they were able to do by averaging over lots and lots of trials is to create a model for exactly what voxels in the fMRI image are active, are illuminated when a person sees a particular kind of object. Okay, so that's the basic idea here. Then what they did, okay, it would be one thing to kind of go back and say, all right, he's showing this pattern, so he's seeing this object. That would be too easy. Okay, what Kay and Gallant and their colleagues then did was to record this subject's activity, again in areas V1, V2, and V3, while he or she viewed 120 completely novel objects that had not been in the original set of the 1,750, and again record the pattern of brain activity. And what they were able to do is to predict from the subject's pattern of brain activity which image he was looking at when he when he displayed that particular pattern. There is the graph. Okay, they were 92% correct, okay, in identifying these objects, where chance is 0.8% correct. Okay, so this is way significant. if you want to do it that way. They actually reran the study. God loved this subject, okay, on 1,000 images, again, and they were 82% correct, where chance performance is 0.001%. So what they're onto here actually is the ability to identify from a particular pattern of brain activity what the person's, well, Gallant wouldn't say it this way, but I can, okay, what the person is consciously seeing, okay, what the conscious visual percept that the person has. Again, we don't know how that pattern of brain activity generated the conscious experience of seeing the Colosseum or a wheat field or a woman on a bicycle or whatever the image was. But we do know what the neural correlate is, that when you see that particular object, that intentional activity, you're engaging in a particular the pattern of neural activity. And just to kind of tease you a little bit, this is Gallant will be giving a talk in the psych department in a couple of days. I'll get the announcement out to you. It's just thrilling work, really. But now they're actually able to reconstruct natural images from the pattern of brain activity, basically taking the algorithm and working it backwards so that you can see here what the image is, and then when they reconstruct it, just based on the pattern of brain activity, you get a pretty good reconstruction of that image. I don't know what it is. I think it's a bridge of some kind. Here you've got some houses and so on. So again, if you assume that the subject was having the conscious experience of seeing the object that was pictured for them, which I think is a pretty safe assumption, okay, now we have some kind of handle on the cognitive, on the neural correlates of this. It's this kind of strategy that will identify that will solve what Chalmers calls the easy problem of consciousness, what Koch calls the problem of the neural correlates of consciousness, by precisely identifying what a person's conscious mental state is, and then identifying that pattern of brain activity which is uniquely correlated with that particular conscious mental state. Again, won't have solved the hard problem, but will take us a long way towards the easier tractable problems of trying to figure out what the neural correlates of consciousness are. Next time, we will zip through the other three mind-body problems, okay? The effect of the mind on the body, bodies without minds, and minds without bodies. Thanks very much.